Hello, this video is on solving a system of equations using substitution. Earlier this week, or last week in class, we talked about solving a system of equations, such as this one, where you might have y equals a number, y equals an equation like 5x plus 2, and another y equals equation like negative 3 minus 7x, and you would solve the equation by setting the two equations equal to each other. Solve the system, rather, by setting them equal to each other. Since y equals this and y equals that, a few of my classes we talked about, then this equals that. Then you could set this equation equal to that equation. 5x plus 2 equals negative 3 minus 7x. And then you could solve using the algebraic methods we've talked about so far this year. This type of system is a little bit different, however, on example A. If you don't have this example, go ahead and print it out. I put it on dashboard for you. I actually emailed it to you as a Google Doc. So in this equation, we have in this system rather, we have y equal to 15 plus 8x, and the other equation is not in y equals form. It's simply, it's in what's called general form, which we talked about in class on today. So what we want to do, instead of setting the two equations equal to each other, you're actually going to take this part, what y equals, this 15 plus 8x, and you're going to replace the y in the second equation with that. You're going to replace this y with 15 plus 8x. So here we go. Here's the procedure. You take the bottom equation, the one that's not in y equals form, and you begin writing it as negative 10x minus 5. And then instead of putting the y there, you're going to stop and replace that y with 15 plus 8x. So we're substituting this expression in place of the y variable. Now we have a single equation with just an x involved that we can solve for x. So let's go ahead and distribute the negative 5. Negative 5 times 15 is negative 75. Negative 5 times 8 is negative 40. Don't forget the x. And then on the right side, we still have the negative 30. From here, we can combine like terms on the left to get negative 50x minus 75 equal to negative 30. And then we will add 75 to both sides. Negative 30 plus 75 is 45. And finally, we're going to divide both sides by negative 50, and you get negative 45 50ths. Or negative 45 over 50 would reduce to negative 9/10 as a decimal, negative 0.9. Okay, so that is the x, that's the value for x that works in this equation, negative 0.9. So what we have right now is half the solution, negative 0.9. To get the y value now, the y variable, you're going to go ahead and take negative 0.9 and plug it back into the equation with the box around it, this guy right there. You're going to plug negative 0.9 in for that x to find y. So y would equal 15 plus 8x. Instead of 15 plus 8x, it's going to be 15 plus 8 times negative 0.9. So y would equal 15 minus 7.2. So y would equal 7.8. So we have a solution, an ordered pair, with x equal to this, y equal to that. So the solution would be negative 0.9, comma, 7.8. And that is solving a system of equations using substitution.